Alright, this video is for trigonometry. Trigonometry of right angles. So you should have learnt in year 10 that there are 3 different ways of finding different parts of a right angle triangle. So we have sine theta giving us opposite over hypotenuse. We have cos theta giving us adjacent over hypotenuse, and then we also have tan theta giving us opposite over adjacent. Using these 3 we can actually find the different parts of a triangle, for example the angle or the sides. So just as an example, find the length of x correct to 2 decimal places. If you have a look, this is on the other side of the angle, so this one's opposite. This is opposite to the right angle, so this is a hypotenuse. So because we have opposite over hypotenuse, we then can use sine. We have the angle being 50 degrees, so that's sine 50 degrees. We have the opposite being x, and then we have the bottom being 4. When we then put this into the calculator, we can choose to use solve if we like, so action, events, solve. This will actually let us find any values that we need to. Okay, and then on the newer CAS calculators, there is a trig tab. We set it's sine, and then we set it's 50. It's equal to x divided by 4, and then we're solving for x here. Putting all of this into the calculator, we should get 3.06. Just a little thing to take notice of, on the very bottom it says we should always make sure that it's in degrees and decimals, so I'll just zoom it down. You should be able to see that my setting says decimals and degrees. If I tap on degrees, there is a grad and there is a rad. Rad's for radians, rad's for gradient, and you don't really need to use it for these, so stick with the degrees. Same with here with decimals, there's a standard form and a decimal form. For what we're using here, we're only going to be using decimal form, so just leave it at that. So just putting the answer back onto here, x is equal to 3.06. Now this is corrected to 2 decimal places, so make sure that you only stick with 2 decimal places here. Okay, find the length of a hypotenuse corrected to 2 decimal places. All lengths are in centimeters. Now notice that this time we have an angle that's in degrees and minutes. When we're doing that, we need to put it into the calculator using a DMS function. When you're putting this into the calculator, the DMS function, the way it works is you put on the degrees first as a comma, with a comma, minutes and then a comma, and then seconds and then a comma. So in this case we'd have DMS 24, 25. I've just really quickly put down what we're trying to find here. We have cosine because we have the adjacent along with the hypotenuse, so we're trying to look for cosine. Just to speed this up a little bit, I've put in the solve and cos part already. So to find DMS, you would go action, transformation, DMS, and then there are 2 options. DMS is for typing in an angle that's in degrees, minutes and seconds. 2 DMS means we're converting an angle to degrees, minutes and seconds. In this case we're putting in an angle that's already in degrees, minutes and seconds, so we have DMS, remember it's 24 degrees, comma, 25 minutes. Okay, now one of the things that you have to make sure with the calculator, you have to make sure that the brackets match up. I've put a bracket on in between 24 and 25 because that's only for the DMS part, and then I'll put on another bracket for the cosine part. if you put it in incorrectly, you will get it wrong. Once we've got that, we've got 7 divided by whatever we're trying to find, so I'm just going to put down x and comma x. Now, just one of the bug fixes. If you've got 7.69, you have the correct answer here. However, sometimes you might not. One of the main reasons I would think that you would not is you may have forgotten to change the settings on the bottom. If you forget to change the settings down here, then sometimes you end up getting the wrong solution. So just reminding you here, we've got a length of 7.69. Now read the question. This says the length's in centimeters, so we need to put it in centimeters. So finding an angle, and then converting it to degrees and minutes. So for this one, because we're converting something, we're going to use the 2DMS function on the calculator. We'll come back to that in one moment. So let's firstly write this out. We have tan theta equals to, now remember it's opposite over adjacent, so we have 18 because that's on the other side, and 12 is next to it, so that's adjacent, so we have 18 over 12. First thing we need to do is we need to rewrite this out. So tan theta, we're trying to find the angle, so we're going to rewrite it out. Theta is equal to tan inverse of 18 over 12. Okay, so that means when we're putting into the calculator, we're going to put that in, the tan inverse. So on the calculator we're putting in tan inverse. We've got 18 over 12. Okay, so we get 56 degrees with certain decimals that we don't need to worry about right now. The main thing is we need to know how to convert it back to degrees, minutes and seconds. So same as before, action, transformation, DMS. Now this time we need to go to 2DMS. So 2DMS, I'm going to copy that straight in. When we copy that in, you should notice that the answer pops up as degrees, minutes as well as seconds. So 56 degrees and 18 minutes. Now with the seconds part, you should notice that that's 35. 35 is bigger than 30, so what that means is we need to round this up. So when we're rounding this up, we initially had 56 degrees and 18 seconds. We need to round that up to 56 degrees and 19 seconds. So one last one. Find the perimeter of the following composite shape, correct to 2 decimal places. Now, this is a composite shape, which means it's made up of multiple shapes put together. In this case, you should notice that we can actually cut it out like so, and we'll actually get a triangle on the right. Now, if you have a look, if we cut this up, this is 20 down here, and we have 17 on the left. However, if we cut this up, we have a section here that gives us some length. We're going to call that x. When we put this straight line down, we should see that on the left we have 17, so this is 17. And then we also need to find this line here, so we're going to call that one y. And we also need to find this length here. Now, there are multiple parts to this, so we're going to split it up. We're going to firstly look at the triangle. There are two things that we need to find on here. However, that's really complicated. We're not going to try and find everything in one single go. So, I'm going to leave y for the next part. So we've got 17 and an x. This is on the opposite side. This is adjacent to it. So then we have tan of 60 degrees, giving us opposite over adjacent. Using similar methods to what we used before, we should see that x is equal to 9.81. So I'm just going to write this in onto the PowerPoint. X is 9.81, now we need to look for y. If we draw the triangle out, we should be able to see that y is the hypotenuse. We said before that 17 is the opposite angle, so we have sine. So then we have sine 60 degrees is equal to 17 over y. Putting it into the calculator, we should get y equals to 19.629, which means when we round it to two decimal places, we'll have 19.63. So I've just put y in on the right hand side. Last thing we need to do, it says find the perimeter, so we need to add all the lengths up. Now we found that we know that the bottom is 20, we know the top is 17. Sorry, the left side's equal to 17. We still don't know this length. This length is 20 minus 9.81, which then gives us 10.19 meters. So we're going to add all the lengths up now. We have the perimeter equals to 17 on the left, 20 on the bottom. On the top we have 10.19, and then y is the other length that we're missing, which is 19.63. Adding all of these up, we should get 66.82 meters. One last reminder, if we're given a right angle triangle and we're not given any angles, remember we can use Pythagoras' theorem, c squared equals to a squared plus b squared, to find any of the lengths that we need.